Hello folks, it's that time again, I'm afraid. Time for your next Red Arrow update. Alright, so let's start off by having a look at some Red Arrow electronics. So, as you probably know, we'll be using our Zombieverter VCU for vehicle control and running our GS300 inverter and all that kind of thing. So not going to get into any of that, that's pretty boilerplate by now, but we are going to be using the new open source CCS controller that's been developed by some folks over on the Open Inverter Forum. I won't name names because, to be fair, I don't actually know. Beyond Johannes, I don't actually know any of the people involved in it. But this case here, this box, you'll probably be familiar with. This is this 56 pin enclosure that I've adopted for the Zombieverter. And I quite like this. It's a good solid box, and this pin header is quite friendly. It's my least hated multi-pin connector, let's say. So I like this enclosure, I like the pin header, I've got a good crimping tool for it, I've loads of them, etc. So last week I got a very nice gift in the post in the form of the actual I think this is called FOCCI, FOCCI board. So this is our open source CCS controller. I've never actually powered this thing up. I have no idea how to utilize it or talk to it at the minute, but I'll dig into that in the future. However, the enclosure and the pin header that the folks chose for this, I actually couldn't find it. Well, I could find it, but I couldn't find it at either a decent price or I couldn't find one place that had all the bits, so all the little pins and locking tabs and all the bits that go along with this. Now I know that this will be sold, I think, on the Open Inverter shop as a kit with all the bits on it. But anyway, I also decided then that I just could not have to deal with another kind of a pin header. So, long story short, too late, what I decided to do, I thought about actually relaying this thing out to fit, this enclosure. But one of the guys on Discord said, well, why don't you just design an adapter board that literally just takes this and gives you the Zombieverter pins. I thought, aha, it's a good idea. I will immediately plagiarize that and pretend that it was mine. So this is the board that we have now. Super simple board. It was my first time making a board to fit this enclosure using KiCad, so I kind of had to start from scratch with this, which is one of the reasons I hate changing PCB packages, but hey, that's life. So, much to my surprise, these guys turned up today and the header is just an absolute perfect fit on there. So I'm delighted with that. And then our FOCCI board will mount on there like that. And that will basically adapt it to the Zombieverter enclosure and pins and so on there. So that's kind of what we're talking about having. So our electronics for the Red Arrow will consist of the VCU and our FOCCI board with the adapter here, so that we'll have two of these enclosures. Now, my experience with CCS with using the i3 limb, as some of you may recall, was that one of the things that it absolutely hated was having the control pilot wire being very long. So whereas I would normally... Really? Now I need to build an electric motorcycle. Anyway, another one. Better this time. Anyway, focus, Damien, focus. Yes. So normally, like, it'd be a nice idea, say, to have these two boxes up in the front of the car in the, you know, where the ECU and so on would normally have been. And I'll certainly do that with the zombie inverter. But the CCS controller, I'm probably going to put that down in the fuel tank area, because there's loads of space back there, and that means I can have a nice short control pilot and plug present signals coming in here. Now, obviously I'm going to have an AC charger in here as well. So what I'm going to do is I'm going to do another spin of this adapter board, but I'm going to put a double pole changeover relay on this. And what we'll do is we'll bring our control pilot and our plug present in here, bring them into the relay. We'll take them back out on the normally closed contact, so they should just come in and loop back out. We'll have a switched 12 volts feed to this guy. So when we're just doing normal at-home charging, or doing AC charging, this can be powered down, so it's not consuming power. And the relay will be on normally closed, and we'll just send our control pilot and plug present back up to the front of the vehicle to our AC charger. Now, when we're out and about and we want to do CCS fast charging, we can just flip a switch, puts 12 volts onto the Focky board here, energizes the little relay, flips the control pilot and the plug present then into the Focky board, so we can do our CCS. So that's my grand plan for Red Arrow Electronics. So now that I've bored you with this, we can go have a look at some of the metalwork. Alright, so first thing you're probably going to notice is that our back wheels here are now off the Greg Pack 6000, and we're on axle stands on the rear. And the reason for that is we want to be able to turn our rear wheels, because as everyone knows, BMWs are rear wheel drive. BMW do not make front wheel drive cars, and do not start telling me that they do. They do not. This is a BMW. It's rear wheel drive. So, front is on Greg Pack 6000, proudly sponsored, of course. And up front, we now have our, let's get you in here a bit better. We now have our front mounting welded up and bolted in, and the weight of our gearbox is now on our gearbox mounting. So it's on our front mount and our rear mount. So I'll hop in underneath here and I'll be able to show you in some more detail what's going on. But it turned out quite well. So just up here on the front, I don't know if I've gone through this before, but what we've got is we've got some box section steel here. I think that's 50 by 50 by 2. And that picks up on the original engine mountings. So I've replaced those with, I think they're Land Rover Defender engine mountings. Come across this way then with our box section, and here where you see the bolts welded into that, there is a piece of heavy wall tube here and here. The reason being, we don't want to crush the box section when we torque down those big 16mm bolts. So let's go have a look in underneath and see how the rest of it works out. Alright, so I should be able to show you, yeah, this full one here. Let me get a bit of extra light. So I'll show you on one side because the two sides are very similar. So my hand in here, can you see my hand? Yes, you can. So we start here, and what you're going to see is up the top there's a bit of solid bar. That's been turned to fit inside this pipe, and it's got a flange on the top where it's been welded to the pipe. Now that piece of solid bar goes all the way down to that elbow, and that elbow and the pipe and the bar are all fused together at that particular joint here, okay? Now that is drilled out and tapped M16 by 2, and there's a super long 16mm bolt, goes all the way from the top down through the box section, down through here, and almost all the way to the elbow. So what you're looking at here is that up to this point here, it's basically solid metal. So that flange is turned back to catch a piece of the bolt tube that comes through the box section and sticks down. So it's not just held in there by the bolt, it's basically grabbing on to that bolt tube, and the bolt is just pulling everything back up. Now we come to our elbow, then we practicing my sexy tigging so that I can, you know, have my own TV show on that. Then we come over here to some horrible MIG welding. It's just terrible, isn't it? Ugh. So anyway, that pipe is then MIG'd onto this piece of 100 by 10 plate here. Again, has one of Tom's favorite triangular pieces in there. Then we are bolted to the bottom of the gearbox, some 10mm bolts just temporarily here. Now this plate here will not be welded to the main locking plate. Blah! Great. Quality videoing, Damien. No TV show for you. Is not going to be welded to it, but it'll be rather bolted to it. And I'll show you the little things that I have for doing that. And the idea is here that this whole thing can be removed without having to remove the gearbox from the vehicle. So, as our front mounting, you can see here on the bottom we have our DC bus, high voltage DC bus connection here for our inverter. It's important to kind of mention this again, that this is where we connect the high voltage here on our inverter, and not where it would have been connected in the original vehicle application, because we're bypassing the boost converter and putting our battery voltage straight in to the DC bus of the inverter stage. Now, you can look a little bit down this way, hopefully be able to see this. You see there's no jacks under the gearbox anymore there now. Everything is kind of pretty much hanging in there by our front and rear mountings. So I'll crawl a little bit further back here now, and hopefully we'll be able to show you some more. So looking over here on this side of the gearbox at the front, you're going to see I've got a little bit of rubber hose looping the oil cooler connections. And that's how I've had it just for doing bench testing. Now, obviously in the vehicle, this is going to make more heat when we're driving it. But rather than have a dedicated oil cooler radiator and then have a liquid cooling radiator as well, what I'm going to do is I'm going to have a little heat exchanger, a little oil to water heat exchanger in here. So we'll be able to just run one cooling circuit then that does everything. And I know this is going to be some shaky cam stuff kind of can't be helped because I don't have the space down here for the I don't really have the space down here for the tripod. Might have to get the Greg Pack 7000 for that. So, welcome to the rear mount. It is in. Needed a slight modification. You'll see there. Got two 40 by 10 spacers welded in there. They lift the tail of the gearbox up a little bit more for me, so that my drive shaft flange here is reasonably in line. So that's turned out pretty darn good. Picked up the drive shaft there only yesterday from Mr. Drive Shaft. Not to be confused with Mr. Shaft Tech. Completely different person, by the way. So, in here, let me put a block of wood under my head. Oh yeah, that's much better. Now, so, this is Lexus all the way to here. And then we join up to our E36 components, which is kind of handy because it has this sliding joint that you can adjust in here. So that's kind of neat. I put a new center bearing on here just because I don't want to be coming back at this. And then all the way from there, further back on is just plain E36. I will be painting the drive shaft and that, but this is just to make sure everything's kind of lined up, and I will have to take out the rear mount and paint that as well. But this is just to get us where we need to be, so we can rotate. Well, if I'm strong enough. There we go. So we can rotate the whole thing. I'm not strong enough. There we go. Just don't have enough leverage. So there we go. We can rotate the whole thing. There's no wobbling or stressing on the donut or on the rear mount here or anything. So that is in and turning quite merrily. So we will be waiting on some components from BMW actually a bit. Yeah, to install. I'll get the block of wood back under my head. Hang on. Because up here, obviously, we'll have our gear shifter, our E36 automatic shifter, and then we gotta connect that up to our Lexus gear shifter lever here. And of course, just like the 450H, this guy is on the opposite side of the gearbox to the BMW one, and also works in the opposite direction to the BMW one, so that'll be great. Other than that, not a lot more to see here. As I say, you will be seeing, we will have a joining piece that bolts together between, let's call this the lower mounting plate and the locking plate here. So I'll show you those in a second. But pretty much it's a nice fit in this vehicle from this angle anyway. Certainly no complaints about it. So these are my little adapter pieces here. They're super simple. Piece of angle and a piece of flat steel. Just welded the nuts on the back here, and then basically the flat part here, just grind this out a bit just so it's clean. This will weld onto the bottom part of the plate, so the kind of mounting plate, and this will weld onto the locking plate here, and this will pull them together on both sides so that we're sharing the load on the front mount across the whole front face of the gearbox and not just the lower two bolts. Alrighty folks, so hope that you have, or maybe even indeed have not, enjoyed this latest update on the Red Arrow. There's been quite a bit of it, a bit of toing and froing between the various parts, and I did really go probably too far on the front mount and all that, but I think it's worked out well, so I'm going to forget about all that and pretend that I of course designed it to be that way. It was super complicated with all those sexy TIG welds in there. So that's enough about that. As usual, don't forget to give all this junk a big thumbs down. Don't watch it, don't subscribe to me, don't support me, for crying out loud, unless you want more cars like this. Nobody does, so don't do it. With that being said, do check the links for the Open Inverter Forum and other people's channels that make much better videos and much better car builds than me. So go watch them instead, or worst case, funny cats. All right, that's it. We'll see you in the next Red Arrow update, or not. And until next time, happy TIG welding practicing.